Recording is started. So my screen is visible.
Yes.
Great. So what we are going to learn today? In the last session, we have completed our net concept. Okay. In English, we completed the net concept, right? English GUI template. No, this is not done for you guys. This is open. We completed just a netting only completed, right? Netting and authentication has been completed. Today we'll continue with that VPN, IPSEC VPN. So before that, there is a many more type of VPN. Okay, so we'll use all this VPN. Okay, so what is the VPN? What is the IPSEC and VPN? What is the IPSEC and their benefits? So let's suppose we have a one B1 branch 1 connected with the internet, and we have a B2. Both are connected with the internet. Okay, and also these are connected with the MPLS. Okay, so if we are having a MPLS, then why we are, what is the requirement of the net? Okay, internet. So MPLS is a little bit costly and slow. Okay, and not stability like scalability. We cannot extend much more distance, right? One more thing, and these are the things which is the draw point of the MPLS, where internet is also, this is a secure. This is a just a, benefit of MPLS, that security is benefit, because it's a dedicated line for you. Only your traffic will run on this, right? So now internet is a cheaper on the in the price base. Okay, and that is a very fast as compared to MPLS, and it is a scalable. Okay, and also not secure. Okay, internet is not secure. To secure this internet, we are looking for, we are using IPsec tunnel. Okay, we are creating one logical tunnel between them, and the traffic is moving towards this tunnel, not towards internet. Got it my point? Clear? Is it clear, Hojipa Moj?
Yes, it's clear.
Yes, sir.
Okay, so now if you talk about IPsec, is providing four features: confidentiality, integrity, data origin authentication, and anti-replay. Now, what is the confidentiality and these all the features? We'll learn one by one. So, confidentiality means your data will keep as secret using encryption algorithm like days, 3 days, or AES. Let's suppose B1 we are having, B2 we are having connected with the internet, and this all are, you know connected with the tunnel. Let's suppose we created one VPN tunnel, and we are sending one data. Okay, from the local lane, one data we are sending. Under this data, what, for the confidentiality, to encrypt the data, this data to encrypt in ciphertext, what will use this days, 3 days, or AES, anything. Let's suppose we are using AES. So AES will encrypt this data. Okay, and send it to the towards tunnel. Okay, so once this B2 is received, branch 2 is received, it will separate both the data and your encryption algorithm AES. If if it if it is fine, then only it will allow to for the inside. Okay, otherwise it will drop the packet. Got it? In the same way, integrity also, let's suppose we are sending a data only here, and along with AES we are sending a MD5 for, integrity. Means MD5 is providing some value. Let's suppose the value of MD5 is 3. So again it will send to the packet, again it will receive, again it will separate the data, AES, and MD5. Okay, so data it will check later. First it will check the AES. Okay, encrypt, there is no alter during the travel. Okay, there is no alter on the data. And also it will check the MD5. It will run, it will check what is the value. So it will, if it is 3 value, then it will it will allow to inside. If it is 3 except 3 anything, then it will drop the packet. Okay, by using so MD5 and SI we are using for that. What? For hazing, right? It is hazing is nothing but it is providing our value with the data. Okay, so remember one thing, whether it is a branch, many whatever branch, one branch, two branch you are having connected with the internet and tunnel with the and you created IPsec tunnel. Okay, whatever attributes it will use for AES, this side also it will use AES. If this side using MD5, this side also will be use MD5 only. Means all the upcoming attributes also will discuss. All the attributes will be same, like pre-said key, so pre-said key, like certificate, so certificate. Okay, like PRIP will be only different, and lifetime if it is same, then lifetime is also required the same. Means many more whatever the attributes using by this IPsec VPN, all the attributes will be the same in the second branch. Okay, got it my point?
Yes, sir.
Okay, data origin authenticator. It means that both device will authenticate to each other before data exchanging using pre-said key or certificate key. Okay, so again B1 connected with the internet, B2 okay connected with the internet. B1 is sending a data with AES for the encryption, MD5 for hazing. Okay, now password, anything password is a ABC, let's suppose. Okay, so it will be like this, the packet will be like this. Got it my point? So if you are using ABC password this side to create a tunnel, we also need to use ABC this side. Okay, the same, if the same password is there, then only the data the tunnel will be established, like phase 1 tunnel will be stable. Okay, the same thing will, because password is required in the tunnel 1, not a tunnel 2. Okay, not a phase 2. Got it my point? Any doubt?
Yes, sir.
Anti replay means, let's suppose again internet B1 connected with the B2. Okay, tunnel tunnel is created, and let's suppose it is sending a data. Okay, so what is trying to say, it means that if your data will arrive late, it will consider the altered and it will be dropped. Anti-replay can be defined in kilobits or second. Let's suppose you're sending one data. Okay, with AES encryption, with MD5 hazing, and some PSK password. This is your data, and it is sending towards tunnel. If man in middle someone is hacked, okay, this this cannot, it is not possible to that to change the MD5 value, or that it is not possible to decrypt this AES. But by any chance, okay, if someone is receive a packet and this value has been it, that guy has changed the value and sending it later. Okay, so what it will it will check, it will see other packet is come, data has come, AES has come, MD5 is also come, PSK is also come, all is fine. I will have later again, if it will sending another MD5, another MD5 with the same data, then the packet will drop, right? Got it my point? Ojipa Moj.
S- w- Sir, what do you mean by data will arrive late? If
Arrive
your
late
data.
means means
Mm.
means means let's suppose I'm again doing the same thing. This is internet. This is your B1. This is your B2. Okay. And this is connected with the B1 and this is connected with the B2. Okay. Let's suppose 1.1.1.1, 2.2.2.2. This is your peer IP. Okay. Peer IP for this will be a peer IP for B1. This will become a peer IP for B2. Okay. Now we given one password. PSK is a ABC. Okay, ABC is a password. So this side also password must be same ABC. Okay, then only tunnel will create. First thing, we are sending a data along with AES for encryption, along with MD5 for hazing, along with PSK, whatever the PSK. Packet has been created. Packet has sent over the tunnel. Okay, let's suppose there is a tunnel, and tunnel, via tunnel the packet is going on. Let's suppose man in middle any hacker is there. Okay, he received your packet. he checked your packet. Okay, data he cannot read. Let's suppose due to AES is already encrypted that, so it is not possible for that. AES, that's fine. MD5, he took a MD5. What is the value for the MD5? 2. To decrypt this 2, to find this value, what is the value of this? Okay, it will take time. So packet will
Mm.
not hold me in between, right? Packet will definitely send one copy. That guy will receive one copy. The hacker will receive one copy. But
Yes.
they cannot stop the packet, right? Once they receive
Yes.
packet with the data, AES, MD5, and the preset key, all are matched. Just allow them. After some time, this hacker is sending one packet with a different value, different hazing value. Let's suppose 2, instead of 2, they are sending a 4. Packet is coming again with the data, AES, because this guy is having one copy, right?
Yes.
So what it will say? It will drop the packet.
Okay. Okay.
Now IPSEC protocol. IPSEC is having a three protocol: IKE, ESP, and AH. IPSEC is using three protocol. So first we'll talk about the ESP and AH. So ESP is supporting, and AH what not supporting. AH doesn't support that what confidentiality. Okay. ESP support the confidentiality and integrity, data origin authentication, data origin authentication, and the anti-replay, all support by ESP. AH will not support what? Hello, am I audible?
Yes, sir.
AH will not support the confidentiality. It will also support the integrity and the not confidentiality, data anti-replay and data origin authentication. Okay, except this confidentiality it is not supporting. So we can say AH is not secure. So that's the reason we are using ESP. Okay, or IKE. So generally IKE we are using under the IPSEC. Okay, version 1 or version 2. Version 1 is also not secure. Version 2 is a secure. So generally we'll use in the real time. IKE only will use in IPSEC. There is a three protocol: IKE, ESP, and AH. ESP and AH we are not using. IKE we are having a two version 1 and version 2. So version 2 is a secure. So we are using version 2 only. Got it? Is that clear?
Yes, sir.
Okay. So internet, what is IKE? It provides a framework to exchange the security parameters and the policies between two IPsec tunnel. Okay. Again B1,
I
again
can't see
B2.
you, sir.
Huh? What is this?
Your screen doesn't appear. I can't see you. I can't see your
My
screen.
okay, let me do that
Okay.
once
Okay.
again.
Okay. It's there. Okay.
Is it fine now?
Yes. Yes.
Okay, so what is the meaning of this? Okay, just a minute. It provides a framework to exchange the security parameters, whatever the parameter means, attributes like AES. AES is attributes, days, days or 3 days for encryption, MD5 for hazing or SA for hazing. Okay, and upcoming slides we'll know about more about the Diffie-Hellman group. Okay, DH value. So whatever that attribute, security attributes we are using, it provides a framework to exchange the security. It secure this, and it is only this IKE is only the responsible to send this all the attributes to each other. Okay, got it? Along with policies as well. Is that clear? Means IKE responsible to send one branch to another branch their attributes over the public networks, or we can say over the insecure network, or we can say over the tunnel also we can say. Okay, so once that they exchange their attributes, once they exchange their attributes, what will happen? It will become like, the tunnel will stable. The tunnel will only stable on this. Okay, got it? Is it that clear? Am I audible?
Yes, sir. Yes, sir.
Okay, IKE is having three modes: main mode, aggressive mode, and quick mode. Either we can go with the main mode or aggressive mode. We cannot use together at a single tunnel. Okay, got it? B1 we are using a main mode, so in B2 also we'll use a main mode. We cannot use both together. Okay,
Okay.
what is the modes and what is that use? I'll let you know. And the quick mode. Okay, IK modes. Let me change the color. IK modes. How many modes are there? IK main modes. It is sending a six messages each other to establish the phase one. Okay, let's suppose this is the phase one
Okay.
tunnel. Okay, this is your phase one tunnel. Under this data will travel. Okay,
Mm.
this will travel. So this is our phase one. This is our phase two, where data will travel. Okay, phase one is
Okay.
nothing but it's a security for phase two. If phase one is down, that phase two will not send the data. Okay, remember.
Okay.
So to establish that phase one, they're sending one message like B1 and B2. Okay, B1 and B2 is there connected with the internet. Okay, first this is, let's suppose this is an initiator, or okay, this is the initiator. Okay, so it will
Mm.
send initiator proposal.
Okay.
Proposal means request. Okay, then it will send, then this B2 will reply with this, that proposal it will reply. So we can say as a responder, this is the initiator and this will be a responsible responder, right? So we can say this responder proposal, this send response proposal, this reply a responder proposal. Okay, first
Yeah.
two message done. Third message, it will send a key. So key, so that key will call as an initiator key because initiator is sending, right? Then again key with responder key. This will say, this will again send a key that will call responder key, right? Then again initiator authentication. This will send authentication. This will send authentication. Okay.
Mm.
Is this just a minute?
Yes.
Sorry. Okay. So this will send B1 and B2. B1 and B2. So initiator proposal, responder proposal, initiator key, responder key, initiator authentication, responder authentication. So this is the six messages. Okay, then only phase one is up. This tunnel is
Okay.
created. Okay, once this tunnel is created, we have, this is about the main mode. Okay, in main mode generally we are using a main mode only.
Mm.
Aggressive mode, the same way, instead of sending a six message, they are sending a three message only. B1,
Okay.
B2. Okay, connected with the internet. This is, let's suppose this is initiator, it will send what? IK aggressive mode use three messages. Initiator will send own proposal with the key. Proposal with key. It will send
Okay.
to the this guy, second branch.
Okay.
Second branch will send, responder will authenticate initiator's proposal and send own proposal. It will authenticate authentication along with the proposal it will send. Okay, it
Okay.
will, because key already sending by this initiator, so key it will also, the second branch will also check the key. Okay, key is matched, so it will authenticate initiator's proposal. It will just authenticate this proposal first message. Okay, after that and send own proposal and key. After that it will sending own proposal and the key. Okay, then again initiator will authenticate the session. This will also authenticate the session. Okay, after that either main mode or aggressive mode will, initiator will authenticate the session. So this is the three message. Okay, first message, initiator will send the proposal key and the responder. Second, a responder will authenticate and proposal, it will send the send own proposal key, proposal and key. Okay, then initiator will authenticate the session. So this, by this is, this is done. Okay, like this is the way how I know how the tunnel is established. Okay, I'll just tell him I'll call you in 10 to 15 minutes. and within an hour. Okay, guys. Hello. Then quick mode. Quick mode. Let's suppose we are having a server in the office, connected with the switch, connected with the router, connected with the internet, connected with the firewall. Okay, and firewall is connected with the internet. Suddenly, pandemic is come like COVID. Okay, people started working from home. Okay, so in the quick mode, we are using what SSL VPN kind of thing we'll use, and will by using this, we'll connect with our private network by using this. Okay. Also, not only that, in quick mode, they will recheck their attributes using SPI security parameter index. Okay. 1 hour. Okay. So SPI is sent with their packet by peers. Means in quick mode, they will recheck their attributes. Okay. Got it? Is it clear? Was that? Is it
Yes, sir.
clear?
Yes. Yes. Yes.
Okay, so this is the way how this tunnel is establishing. Now there is a phase one and phase two. So if you talk about the phase one and phase two, this phase 1.5 is a optional, so we cannot discuss about this. Okay, so in the phase one, what is this, man? Okay, in phase one, if you talk about the phase one, initiator and the responder will use single key to authenticate and build the tunnel. Okay, that is fine because both the sides same key, same password. If main mode will work, aggressive mode will not work. As I initially only informed, like either work by aggressive or the main mode only, right? So it depends on IPsec VPN. So side to side VPN is using main mode. DM VPN is using main mode. Sorry, side to side using main mode, DVM VPN using aggressive mode, gate VPN is using main mode, remote access VPN using aggressive mode. So these are the type of VPN which are using aggressive mode or main mode. Okay, clear? So we cannot talk about the 1.5 phase 2. When phase 1 is successfully completed, phase 2 is started. If phase 1 is not successfully completed, phase 2 will not start. In phase 2, they create multiple IPsec tunnel to tunnel per protocols ESP or AH. Okay. So in phase 2, once phase 1 is up, then only the phase 2 will start working. Okay. Then only we can configure the phase 2. Clear? By using ESP or AH. Okay. We can create multiple tunnel, but we are remember we are using IKE either version 1 or other version 2. So now ISACM, IKE is management protocol. IKE is a management protocol. IKE use ISACM for proposal exchange. Proposal exchange, like initiator is sending proposal, right? And responder is also sending a proposal, correct? Are you guys there? Wajifa,
Yes, sir, we
Moj,
are
are you
here.
there?
Yes, yes, sir.
Okay, so this proposal is sending by ISACM. ISACM stands for Internet Security Association Key Management Protocol. ISACM is using UDP port number 500. Okay, so ISACM is the only responsible who sent what? Who sent proposal by using IKE. Okay, IKE version 1 or 2. So after that IPsec modes, there is two modes, transparent mode and tunnel mode. So what is the difference between? Let's suppose what is trying to say transparent mode. Transport mode. Okay, transport mode encrypts only the data portion, not the IP header. This is a data. Okay, this is your IP header. Means layer 3 address. So what transparent can do? Sorry, transport mode can do only, they can check only data, not they can't check the IP header. Okay, so transport mode is not secure. Tunnel mode is having a power to check the data and the IP header as well. Okay, tunnel mode is used site to site remote access and gate VPN. Clear? Security association, a group of security parameters in the policy which is generated between two IPsec peers. SA component, SAID like Security Association Database, SPD Security Policy Database, Security Association Database. It contains peer IP. What it contains a peer IP? These Security Association is contains a peer IP like one branch IP, second branch IP. SPIs, SPI which is sending for a proposal, right? IPSEC protocols, whatever the protocol that is using. Okay, IKE, ESP or AH. If it is ESP, then ESP, then AH means AH. Okay, or IKE means IKE. Whatever that, all this will handle by security association. Okay. So security policy database, it contains encryption algorithm like days, 3 days or AES, Hayes algorithm, MD5 SAR, IPSEC mode, tunnel or transparent transport, key lifetime, second or kilobytes. Security policy database. I believe that you guys are not getting understand by just about this introduction. But when we'll do the configuration, it will come into your mind. Okay, it will be clear into your mind. Okay. So SPI and DH. What is the SPI and DH group? Security parameter index. Both devices create a haze of security policy database. That haze is called security parameter index. DH group. Diffie-Hellman allows two parties to share a secret key over an insecure network. So whatever the secret key, like I'm using ABC, right? So this side also using ABC. So this is DH group is having Diffie-Hellman allows two parties to share a secret key, like both the parties, B1 and the B2, both are the parties. So both the parties is allowing to share the secret key. Okay, clear? How is Mojipa?
Yes, sir, clear.
Yeah, now I'm just stopping the recording. In the next session we'll do the practice. Okay.
Okay, sir.